A is definitely positive. Look at it. A is definitely, that means it will be a kind of parabola that is facing up. So that means this way you are going to have a curve. End up like this. So if you are having a curve like this, remember that at this point, it will not pass through 0 since 0 is not one of the stuff. So it will just cut like this and go like this. So then maybe at this point, maybe you have -3 here. At this point, it's -1. At this point, it's now 2. You can see what I'm talking about. So that's the way you have it. So it will cut to the 3 critical values, x equals to -3, -1, and 2. So let's go to our option and see how it will look like. So in our option, the one that will be x equals to -3, x equals to -1, and x equals to 2. X equals to -3, x equals to -1, and x equals to 2. So option C will be the solution to this question number 19. Now, question 20. That is a polynomial in x whose zeros are this, and this. So if you are given a question like this, that means they've given you the value of what? The values of your x. They gave you x to be equals to -2. They gave us x equals to -1. They gave us x equals to 3. So these are the 3 critical values of our x. Now, if you want to solve this kind of problem, you assume that if your x equals to -2, that's the solution, then what will be the factor? You transfer it to the other side. So you have x plus 2 will definitely be what? A factor. Take note of that. If x is equals to -1 is a solution, then x, transfer it again. It becomes x plus 1. So x plus 1 is a factor. The other one too, when x equals to 3 is a solution, transfer it. X plus 3, when it crosses, it becomes -3. So x minus 3. You have seen these are the factors of the polynomial. What do we do next? We bring them side by side, or we place them side by side and open them up in form of expansion to get our original polynomial. So what am I saying? This times this, x squared. This times this, plus x. This times this, plus 2x. This times this, plus 2. I have solved this first one. Let me still leave this one here. Let me simplify this. X squared plus 3x plus 2. Then I have x minus 3. So what am I saying next? Then I pick x minus 3 into x squared plus 3x plus 2. I have not committed any mathematical block because I know that by law of commutative, AB is the same thing as what? BA. That was why I brought this one in like this. Then in that situation, x into x squared plus 3x plus 2 into minus 3 into x squared plus 3x plus 2. What did I do? I pick this, I used to open this, I have it like this, minus 3, I pick it again, I used to open it. You can expand that way. Then that is so by so doing, this time this x cubed plus this time this 3x squared plus this time this 2x, this time this minus 3x squared, this time this minus 9x, this time this minus 6. So what do we need to do next? We need to simplify. This one does not have the mates, so you put it directly. But this one has the mates. Look at this, plus 3x squared minus 3x squared, they will cancel out. Then you have plus 2x minus 7x, that becomes minus 7x. What is the last one? The constant, minus 6. So we go to our option and pick the option that has this, that correlates to this. X cubed minus 7x minus 6. So by so doing, let's see the one that will definitely fit in. The option B will fit in. So x cubed minus 7x minus 6. Now, question 21 says that find the roots of this. If you have a question like this, and the question asks to find the roots, you have got no other choice than to resolve into using, you test for the values, the critical values of what? X. So you have x cubed minus 2x squared minus 5x plus 6. So that means I'm going to have x equals to plus or minus 1. That's what I'm going to test. So I want to test for x, because this is the simplest you can test for. So let's see if x equals to 1. Because if x equals to 1 and you substitute it here and you have a 0, that means that is the critical value. So we want to try the critical value of x that will suit this. So let's use x equals to 1 first. So when x equals to 1, I have 1 cubed minus 2 into 1 square minus 5 into 1 plus 6. So this one is 1 minus 1 square is what? 1. 1 times minus 2 minus 2. Then you have 1 times minus 5 plus 6. So 1 plus 6, 7. Minus 2 minus 5 minus 7. So that's 0. That means x equals to 1. Then x minus 1 is a factor of this. So let's resolve into long division rule. So x cubed minus 2x squared minus 5x plus 6. This divided by this, x squared. Use this to multiply these two terms. This time this, x cubed. This time this, minus x squared. Then we line, then you subtract. This minus this, 0. This minus this minus this, that will give us minus x squared. X divided by minus x squared minus x. Minus x times this, meanwhile, minus x times this minus x squared. Minus x times this plus x. Then you bring this one down, minus 5x. Then we use another minus. This one becomes 0 again. Then this one becomes minus 6x. Minus x divided by minus 6x minus 6. Minus 6 times this minus 6x. Then minus 6 times this plus 6. And bring this plus 6 down. And we'll have, so it produces a minus 0, 0. That means this is the second quadratic expression, which we are going to now solve by factorization to break into 2. Then in this situation, we are going to have minus 3, 2 as our factor. Then we have x squared minus 3x plus 2x minus 6. Then we have something like this. What is common here? X is common, x minus 3. What is common here? Plus 2 into x minus 3. Then we have x minus 3. X plus 3. Plus 2 rather. Then meanwhile we have x minus 1 initially. Then we have x minus 3. X plus 2. Then we now equate each one to 0. So x minus 1 equals to 0 implies that my x equals to 1. X minus 3 equals to 0 implies that my x equals to 3. X plus 2 equals to 0 implies that my x equals to minus 2. So I go from minus 2, 1, 3. Minus 2, 1, 3. So although it's not arranged in order of magnitude, so we have to trace that. Minus 2, 1, 3. I think this one is the answer. So the answer is A. Option A is the correct answer to that question. Then the next question is saying that a polynomial in x whose roots are this and this. So the question is, this question 22 is not different from question 20. So the same thing, but the only thing is that it is a fraction this time around. So what do we need to do here? We know that our x equals to 4 over 3. That's same our x equals to minus 3 over 5. So in this situation, we transfer this on the other side. We have x minus 4 over 3. Then we have this one. This one becomes, transfer this on 3 over 5. What's the SCM here? What's the SCM here? SCM is 3. We have 3x. We have 3x minus 4. Then what's the SCM 5? We have 5x plus 3. So that means we are going to be having, so if we are to solve this one quadratically, remember that these are the roots of the equation. So based on what we have here, we can use a model. without wasting much of our time, we can use a model that says that x squared minus alpha plus beta, that's sum of roots, x plus product of roots equals to 0. Let's use this model. So we know that our alpha here, let this one be, our alpha here is this, our beta here is this. So let's substitute that. We have x squared remain the same minus, what's our alpha? Our alpha is 4 over 3 plus what's our beta? Minus 3 over 5 affected by x plus 4 over 3 multiplied by minus 3 over 5 equals to what? 0. That's our model. So here we have x squared minus 4 over 3 plus times minus 3 over 5. You can put in the bracket affected by x plus, should not be plus any longer. This is minus times this minus 3 can cancel 3, and I have 4 over 5 equals to 0. So let's simplify this. What's the LCM here? 15. How many 3 are we going to be seeing? 15. 5. 5 times this 20 minus how many 5 are we going to see? This 3. 3 times this 9. So we can put this one in the bracket like this, affected by x minus, then this one will be minus 4 over 5 equals to 0. So let's simplify this. We have x squared minus this, that's 11 over 15x minus 4 over 5 equals to 0. What's the LCM here?